Hi, I'm Phil Wishuren from Right Maths, and today I want to talk about rotational symmetry. Okay, so it's a little bit like putting a biscuit tin lid on a biscuit tin and saying how many times can I spin the lid around and it still fits exactly on the biscuit tin. Well, here's my first shape, and I have drawn or traced over it with the same shape, and I've fitted it on once already, so I've written one at the top. I've also drawn a little arrow so I know which way round the lid or the tracing is. Okay, so it's gone once. I'm now going to spin it round, and I can move it 60 degrees and I can see it almost fits on top of itself. The black lines fit on top of themselves, but you'll notice the circles have all gone black. The black circles have gone on top of the white circles. Well, that doesn't count. A black must go on top of a black. So I'm going to move it further on, and you'll see now that the white circles go on the white and the black goes on the black. So now that is a perfect match. So I'm going to write 2 here because everything fits. Okay, I'm going to keep on spinning now. So there it doesn't go because it's black on white. That doesn't count. Oh, it's now black on black and white on white, so that counts. So that's 3. You might be tempted to think now that I can spin it around again, but let's do that. And actually I'm back to where I was, so that doesn't count. So the order of rotational symmetry is 3 in this case. Let's go on to the second shape, and I'm going to write 1 at the top because I've fitted the shape on top of itself. We'll spin it round. It doesn't fit that way because the circle doesn't fit on top of itself. It does fit that way, so I can write a 2 at the bottom now, and then I'll try it the other ways. That doesn't work. The circle doesn't fit on top of a circle, and then we're back to ourselves. So the order of rotational symmetry is now 2. Okay, well, let's do the third part, or part C of the question now. And it says shade exactly 2 more squares so that this diagram still has rotational symmetry of order 2. Well, I'm hoping from the previous 2 examples that you can immediately spot that this does have rotational symmetry of order 2. You can spin it through 180 degrees and the black square will go on top of the black square. If I want to keep that rotational symmetry with an order of 2, then any squares I have to have a rotational symmetry of order 2 themselves, or at least the complete picture does. So I've got 2 ways I can keep that rotational symmetry of order 2. I can add these 2 squares because they have a rotational symmetry of order 2, or I can add these 2 squares, which also that diagram has a rotational symmetry of order 2. Let's try this one first. Let's shade these 2 squares in. So I'll just overlay the other 2 squares that I've got. Now I'm hoping that you can immediately spot that the rotational symmetry is order 4. There are 4 black squares. Each time you turn the shape through 90 degrees, a black square turns onto a black square. So order of symmetry 4. That doesn't answer what the question's asking for. We want order rotational symmetry of 2. So let's discard that. Let's try this one. Well, that's a lot better. If you were to spin this shape round 180 degrees, you would find that the black rectangle at the top spins round and goes onto the black rectangle at the bottom. So the order, or the rotational symmetry, has an order of 2, and we've answered the question correctly. We fill in these 2 squares. Okay, I hope you enjoyed the video, and if you did, please subscribe to my channel and also have a look at rightmaths.com, which is my